We are live. I'm Step 2.0, and today I'm speaking with my friend and Epicenter co-host, Sunny Aggarwal. He's also the co-founder of Osmosis, the greatest DEX in the interchain. And we're going to be talking about a whole bunch of things today, starting with mesh security and how it aims to radically shift the security model in the Cosmos. We'll also talk about the Osmosis ecosystem, permissioned CosmWasm contracts, and Atom 2.0, and why he's not so bullish. Before we get started, make sure to subscribe, hit the like button, and the notification bell to get notified when we do new live streams every week. My guest, Sunny Aggarwal, is coming up next, right here on The Interrupt. Hey, Sunny.
Hey.
Welcome to The Interrupt for the first time. I mean, no, actually, you were kind of on The Interrupt at Cosmoverse, but yeah. But like actually properly doing you as an interview. So yeah, thanks for doing this, and I think it's gonna be interesting.
Thanks for the intro. I'm just going to say in the intro, I never said I'm not bullish on Atom 2.0. I actually am bullish on it.
we gotta get people hooked, right? You gotta make it spicy. Yeah. So what's going on? How you been since Cosmoverse?
Good. Been getting back to reality a little bit. Took a few days off after Cosmoverse. Just went around Colombia a little bit. And then this week we're having a lot of our team is here in Berkeley, just grinding away on a bunch of stuff, trying to get a lot of cool features shipped by end of year.
Yeah, well, let's dive into some of those cool features. Yeah, by the way, I mean, like, what was your kind of takeaway from Cosmoverse? Like, 2 weeks out now. When the dust has settled. What did you think?
I think just a lot of really cool growth in Cosmos. Definitely a lot of people interested in, like, I think a lot of the projects that are building stuff on top of Osmosis are really like starting to get to the point where they're almost ready to deploy now. You have like Mars and Levana, and a lot of these projects are like real, like I think we're gonna, in the coming like month or two, we're gonna start seeing a lot of deployments happening really quickly. We're already seeing that some of the a lot more contract deployment proposals going on to Osmosis these days. So so just excited to see those. And then otherwise, I think just been a lot of interesting discussions around Atom 2.0 and stuff. I think like I feel like it's a little bit more controversial than I guess I had originally expected it to be.
Yeah, me too. Yeah.
And then I think just in general, everyone seems really excited about mesh security as well. So yeah.
Yeah, and I think it's interesting that we have really kind of two visions here that I think aim to achieve similar goals, but that are just in the implementation so different. And I do agree that it feels like since Cosmoverse, Atom 2.0 has just monopolized the entire, like, all of the attention in Cosmos. Like, everyone's talking about it. Like, we did a podcast here like 2 days ago, kind of debating from the community side and from the hub side, and lots of really interesting insights. And like, I see people are sharing, like, here, I'm going to publish this blog post about Atom 2.0. Like, what's your feedback? And like, everyone's kind of like trying to position themselves about like about their opinions of the proposal. And I think like the main kind of takeaways for me is, and that maybe I think the ICF, like, okay, first of all, like, this is a huge document, like a ton of work went into this paper. You can't discount like the amount of work and research and that went into this paper. So like, the authors definitely like deserve some praise for that. I think where things failed maybe, and I want to say, like, in true ICF fashion, is like the communication around it wasn't great. And particularly, I think that they I think they've kind of failed to make it clear that this was a signaling proposal and like this was meant to spark a discussion rather than like this is a thing that should be taken at face value and then we're going to implement it. Like I was saying on the podcast, like Zaki's talk should have had like draft written all over it, and the paper should all have like draft written all over it, and it should have been like this message should have been just like hammered, like, hey, we're putting this out there. Now we're going to talk about it, which is exactly what's happening, but just like all of the kind of negative feedback and pushback I think comes from this kind of weird feeling people have, I think, in regards to the ICF and like how it communicates and it's not so transparent. And I really hope this changes, but I feel like that was kind of a missed thing. Anyway, so let's talk about mesh security. You guys implemented it, or at least you implemented like a preliminary version of mesh security at the hackathon right after CosmWasm.
Very proof of concept, but definitely getting
there. But there's a repo, there's code, there's contracts, so like and people are contributing to it. Like what's mesh security for those who missed the talk? We'll link to the talk, but like give us a high level.
Mesh security is this, it's the kind of the entire point of how Cosmos shared security was designed from the get-go, which is like, we want, we've always been building up this world of sovereign app chains. And now it's time for, we need to get more secure. Every time we talk to someone about this app chain vision of like, hey, a DEX app chain, a lending app chain, a gaming app chain, all these things are going to happen. And then people are like, what about the security of these? Like you need an L1 for security. You need base level Ethereum level, like a level of security. And it's like, so that's always been like a question of like, oh, how is that going to happen in these app chain world? And the answer now that we have is, well, all these app chains are going to secure each other. Like, maybe any one app chain might not have the same security as like an L1 with like base moneyness and stuff, right? But like all the app chains together will have enough security. So, an example, I gave was, if you look at like the market cap of the highest money asset, it's gold, right? It's like $11 trillion, but the market cap of the 10 biggest companies, like stock market caps, added together is actually more than $11 trillion. So this like the sum market cap of all the app chains companies is higher than the money, which is gold, right? And so I think that we can get higher economic security by all these chains pooling security together in almost like a NATO style model, right? Like NATO is like sovereign countries, like France doesn't go intervene in the UK's internal politics, but it's a mesh of security alliances that if any one country gets attacked, they all rush to each other's defense. And so this is kind of how chains will work as well, where they all are sovereign, have their own governance systems, but they should all be like sharing security with each other in a mesh system. And not necessarily all chains share security with everyone else. What happens is chains share security with the ones that they have economic dependence with, right? And so an example would be Osmosis and Axelar. So Osmosis makes up over 70% of Axelar's entire TVL right now. Meanwhile, 4 out of the top 10 assets on Osmosis come via Axelar: ETH, DAI, USDC, and WBTC. So it's like, okay, these two things are so economically intertwined. It would really suck for Osmosis if Axelar got like attacked, right? So it is in Osmosis's best interest to help provide more security to Axelar in the same way that it's in Axelar's best interest to help provide more security to Osmosis. And so these two chains will want to do shared security with each other. And so our entire view here is that like these economic dependencies and reliances are what's going to lead to security alliances as well. And so, and then obviously, which chain in Cosmos does almost everyone have some economic dependency on is Osmosis. So obviously, from Osmosis' perspective, we're hoping that there's ways to turn our economic relationships with all these chains into valuable security relationships as well.
Yeah, okay. But Sonny, these are all just fiat economics. This doesn't really secure anything. All the validators are the same.
Yeah, I mean that's a good thing, right? That shows that like, hey, the teams here are like, there's high overlap in communities and like economic stakeholders, which gives more reason why there should be like a mesh of security systems across these chains. Imagine a validator does something malicious on one chain; they should probably be slashed on all the other chains as well. You probably want validators to be correlating their identities across chains, and then the goal here and the fiat economics are important, right? Because how do you take over a chain is you buy up enough of the tokens to do a 1/3 attack or a 2/3 attack or something, right? And if you increase the economic cost of buying up that 1/3 of tokens, that is how this fiat security is literally, I mean, that is what proof of stake is. That's the entire point.
Yeah. No, I was being facetious there. I'm
Yeah.
trying to trigger you a little bit, but you've been through this before, I think. Yeah. So,
I've
what
only
are
been
some of the?
claiming proof of stake as a concept for the last 6 years.
Yeah. So, what are some of the non-obvious like properties that emerge from mesh security? Like, what are the things at the edges that emerge that maybe just like looking at it here, we're not really seeing. But if mesh security does become sort of the norm in the interchain, and we have like all the chains securing each other, like what kind of other properties you think might emerge?
Positive or negative?
Both.
Okay. Positive, I think it will like, increase the ease of interacting between chains. So, instead of having to think about, oh, what is the security threshold of different chains, part of the whole claim of like Ethereum, oh, it's easier to compose. It's not actually easier to compose from any technical level. What they mean is they say it's like you don't have to think about the economic security levels of different rollups because they all use the same security. So first of all, that's not really true, but like that's the claim at least. And so the idea is by having this mesh system, it's sort of like, make the economic security levels of all these chains much more closer to each other, and that will make it easier to do like more trust free or not trust, yeah, more carefree, I guess, cross chain composability. So that's like one of the benefits. A con that what we've so like uh the like informal team had actually been working on like stuff that like kind of leads to this, but they kind of actually paused because on like interchain security v2 and v3 because they ran into some roadblocks in the architecture, especially things around validator centralization and chain takeovers and all this kind of stuff. And so what we had to do was like figure out solutions for these things. And so you know it's still an open question of like, hey, will this lead to too much validator centralization where it's like it makes it so like the few validators that know how to run on 50 chains will get like unfairly benefited from mesh security? Or how do you make sure that a giant chain doesn't just come and entirely take over a tiny chain and stuff? So I think there's a lot of like open questions, and I think our mesh security design has like answers to those questions, but obviously these are theoretical answers that sometimes it's just hard to know everything until we start put it into practice a little bit.
Yeah, I think that the validator centralization thing is the thing that I haven't really fully kind of wrapped my head around yet. So, like in your talk, and I've heard you talk about this in other places as well, where you say that we should stop thinking of validators as the fundamental unit, but we should think as delegators as the fundamental unit.
Yeah.
I kind of get that, but at the end of the day, the validate, like from a governance perspective, but like a validator infrastructure company is an identifiable, like capturable, like by regulation or whatever entity. And also there's this idea of also like infrastructure centralization, where like if you have most validators on AWS, like practically speaking, if AWS goes down, the chains go down, right? Like delegators are not going down in the same way that validators are going down.
Yeah.
Am I missing something here, or like what
Yeah.
is it? Are we operating on the same semantics here when you're talking about the fundamental unit?
Sure. So I guess like mesh security is this like high level idea that chains should be sharing security with each other. But keep in mind, there's actually different types of security, right? There's like economic security, there's infrastructural security, there's like, you know, and so like I think the validator level is more like infrastructural, where one thing you want to do is maybe get validators to start correlating identities across chains. And that way, let's say one validator does something malicious on Osmosis, they should get slashed on Juno and Axelar and DYDX and everywhere, right? And that's like that's more at the validator level, and I think that's a good idea. The worry is to get incentivized validators to do that. We need to give them some incentive to correlate their identities, and if they get some incentive to do that, that's what we're worried about leads to validator centralization, which is why we actually put that model of mesh security like on the side right now. That's not the version of mesh security we're building right now. I think we can build that, but like that we do have to answer these questions about validator centralization. That's why the version of mesh security we're mostly focused on is this cross-staking model. Cross-staking is this idea that like delegators, I can choose to cross-stake my Osmo on Osmosis, that's staked on Osmosis, to also help. I can stake it on a different validator on Juno. There's no benefit of like one validator running on multiple chains in the cross-staking model of mesh security. This is all just about adding more economic security to all of these chains. So that's why. So in the cross-staking version of mesh security, there is no notion of validators correlating identities across chains.
Okay. So in this version of mesh security where validators correlate identities across chains. So the goal here is like, let's create an on-chain kind of identity where like we know that this address, so like interrupts validator on Avmos is like the same as this other validator over here. Like that might be obvious by just looking at the list of validators, but we want to make that like an on-chain sort of representation, because you might have like different validators that have different names. If you're trying to obfuscate your identity, that might be the case, but we want to incentivize people and we want to incentivize validators to actually correlate their identities across chain. The idea here is that they would receive an incentive, and financial incentive for doing so. But at the same time, like the risk is that like they get slashed across different chains, and chains need to coordinate around like this slashing. And you're talking, I've heard you talk about this before, but basically you're saying like this kind of already exists, right? Like if there was a big enough attack by a validator, we would use governance, or we would use some other mechanism to apply some kind of penalty. But here, we're moving that penalty to like an on-chain mechanism that like essentially just like runs through consensus.
Yeah.
Okay. Let's walk through how this works, because you guys have like a really good flowchart thing here, and like I'd love to get into like technically, what are the different steps here. So for those listening on the audio version, you should check out the YouTube video. So here we've got like Osmosis and Juno, and walk me through the different modules and different contracts that that interact here with.
Yeah. So for some context, this is actually what we built at the Aggarwal hackathon right after CosmWasm, after Cosmoverse. I'll be completely honest. I wrote almost no code for this. It was mostly Ethan Fry and Jake Hartnell who like hacked on this like 3 days straight and like actually got something working. So that was like super cool. But that's really cool. Which is like keep in mind, this mesh security thing is not an Osmosis project. This is just like a idea that we came up with, and like the Juno and Confio teams have been like stepping up to do development. More people have been starting to help the development of this. So what we helped with a lot was this architecture. And part of here's something interesting that we'll say is like what people might notice is that the architecture of this is extremely similar to the architecture of superfluid staking. Because if you think about it, what is mesh security? Mesh security is saying, hey, the governance of my chain, let's say, so who's the consumer chain? It's Juno in this example, right? The governance of Juno gets to say that like, hey, I want to opt in to let this other token that's not my native staking token count toward use governance to approve that, let it count towards staking power. We need to be able.
I think we lost Sunny. Let's see if this works. All right. Oh, here he is.
Hey.
Okay, we lost you there.
Yeah. What was the last thing you heard?
You were talking about how basically you're allowing
Yeah.
the other chain to accept your security.
So in trust staking, it's like the consumer chain is making decisions about which these other token assets, these IBC staked assets, to allow to count towards staking power, be slashable, give rewards. Superfluid staking was the same thing, right? It was osmosis governance saying, hey, we trust these LP assets enough.
Yeah.
It's actually making a decision about another token because it's
Yeah.
often paired with something. Say, we trust this asset enough to let it count as part of our staking system, give it rewards, and have it be slashable. So one of the reasons we were able to architect this kind of quickly in less than a day was because it really was taking our superfluid staking design that we had spent weeks, months on, and we kind of just broke it up into a number of contracts and have added this IBC barrier at it somewhere. But a lot of it was really the same design. So okay, so what do you want me to do? You want me to walk through this entire slide deck? You're muted. Sebastian, you're muted.
Yeah, so I think here that what we can do is say, okay, let's start here where Osmosis approves cross-chain staking and enables this CosmWasm meta staking contract.
Okay, so here what happens is Juno is the consumer and Osmosis is the provider in this situation. Keep in mind, mesh security, the idea is that we'll have this instantiation and we'll have the same thing going in the other direction.
Right, so this is one side and then we'll have another side at some point. All right, and so then at some point,
Juno gets
Osmosis...
so Juno says, hey, they use governance to say we're going to let Osmo cross staking count, and then they'll put some cap on how much maximum. This is to prevent the whole chain takeovers. So okay, they cap it at 10%. What it does is it deploys a contract on Osmosis that is on Juno. It's a mesh consumer contract. And then this mesh consumer contract basically deploys a corresponding contract on the other side, which is called a mesh provider contract. So if you go to the next slide. And then this mesh provider contract, it has a special plugin to another contract, which is all the specific details about how, about Juno, right? Because, this is so that we can add more consensus protocols, more types of slashing conditions and stuff over time. So this is called the slasher contract. And then, it opens this trusted IBC channel between the contracts. And what it does is it allows... I can't see the slides. Hello?
The joys of being in the woods, man.
Maybe it's, I don't know. I don't think it's maybe the best thing for me to walk through these slides right now. I think the walkthrough was available on YouTube, and we can have people walk through it because it goes pretty technical. But the idea is basically, I think the general high level idea we wanted to show was that look, what it does is it allows you to take Osmo on Osmosis that is staked on Osmosis, say, hey, I am going to opt into an additional slashing condition and back this validator on Juno. And then that information gets transmitted over IBC, and and the Juno system will accept that as voting power. And then
Yeah.
if a slash happens, it'll send that information back over IBC, or you can submit the double sign evidence directly to the contract on Osmosis. The reason you don't want to depend on IBC for the submitting of slashing is the whole point here is we're trying to deal with a Byzantine chain. Like, what if Juno goes malicious and it starts censoring the evidence, right? So what we want is the ability for like double sign evidence to be submitted directly to Osmosis, so it doesn't rely on the liveness of the Juno chain for slashing purposes.
Yeah. Okay. And so when this is implemented, the provider chain. So who's getting incentivized here? Like the validator, the delegator, and also the chains are who's making money from this operation?
So the delegator, the cross stakers are the ones who are getting rewards, basically, right? They get treated as stakers. So similar to how in superfluid staking, right? If you are superfluid staking your pool one shares, it's counted as like, hey, this is being treated as this much Osmo worth of stake, right?
Yeah.
And you're getting staking rewards as if you staked that much Osmo. It'll be the same thing here where, okay,
But it's less, right? So with superfluid staking, you're actually making less.
you take a little penalty. Yeah, you take a little discount on that, right?
Yeah.
That's good, right? Especially for cross staking, we want, if you want to be maximally exposed to Osmosis, you should be pure staking Osmo. The cross staking Juno to secure Osmosis is like a benefit. It's a nice bonus that Juno stakers get. But like, you still do want people to natively stake the assets that, let's say they're the most bullish on.
Yeah. Well, I'll link to this flow chart in the show notes. People can look at it. Also, a link to the repo. People want to take a look at the code and all the contracts. So when this happens, then Juno is benefiting from essentially having Osmo staked to secure Juno. So this is, I think, like the mind shift that people need to have is that they're no longer securing Juno with Juno. They're securing Juno with Osmo. What are the implications here for say chains that have less security? So like in the interchain, we have chains that are more secure than others, and we have chains that are less secure than others. So how do we reason about the security implications that this has for chains that are maybe taking security from other chains that are like less secure?
So so a chain that's like less secure getting security from a bigger chain, I think the benefits are obvious, right? They get way more economic security. But a big chain, why would they want to take security from a smaller chain, right? I mean, like I said, the whole point is you shouldn't necessarily have to think about it as a one-to-one thing. This is a mesh, right? And so even if like, let's say like a big chain like Osmosis gets security from 10 smaller chains, maybe that could meaningfully double its security budget. So, it's often like, hey, people are like, oh, why does the US get anything out of NATO? Isn't it like US is just the only one providing anything to NATO? It's like, yeah, sure. Like the US maybe has, outsized influence relative to any one other country in NATO, but like the sum total of NATO is like, the US definitely gets benefit from like the sum of all other NATO countries also helping secure the United States.
Yeah, I actually have this here in my notes. NATO example, the US is the biggest security provider.
Yeah, but like, is it like more than it's not 90% of the security budget of NATO, right? And it's like it's
I
still
don't know.
benefit. There's a reason it's a security alliance, not a empire colony model, right? Where the security still does flow bidirectionally, multi-directionally.
Yeah. No, this is cool. So what is the what's the rollout here? Like when should we expect to see this on Osmosis? And like are there other chains that are already thinking of implementing this as well?
Yeah, so I think like Juno and Eve, which is like Notional's like canary chain that they're building. I think there's a number of chains that are like planning on implementing it. I mean, realistically, I was not expecting for development to even begin until like January, because like I said, we have, at least from the Osmosis core dev team, we have like a roadmap that we have that was like, planned until December, and we were like, okay, we're gonna pick this up in January. But like I said, people were just so excited by the concept that they're like, no, we want to start working on it this weekend. So I mean, realistically, we're not going to see anything live, at least until next year for sure, right?
Yeah.
But at least I think the development has already kicked off, and we're going to hopefully see it. I don't know. I imagine we're going to see like a prototype live, definitely within like the first half of 2023.
Okay. And what are so one thing I was thinking about here is like,
maybe I got to commit to shaving my head, and maybe that will help move it faster.
yeah, let's do that.
No,
Here on the interrupt,
not
Sonny
again.
is committed to shaving his head. So what are the implications here if you want to do liquid staking, but you don't want to do it on Osmosis? So let's say you've got your Osmo staking over on Juno, but you want to use that staking position on Quicksilver, to like generate some liquid staked asset on Quicksilver. Could you do that? Or is it going to be somewhat? Is it going to be like a lock-in?
One more time.
Sorry. Yeah. So you've got Osmo. Yeah. Mad Cat knows that you're going to shave your head, so he's our witness. If you've got Osmo that is staked on Juno, right? So you've got a staking position on Juno, but you want to generate a liquid staking token. So can you take that share, that staking share that's representing that Juno stake, and like move it over to Quicksilver and generate a liquid staking asset? Is it the same as if you had just had Juno stake there, or is it sort of like already some sort of staking derivative?
No, so keep in mind with staking derivatives, how they have to make it fungible is they need to make sure that all of these staking derivatives have the same slashing properties, right? And that means that like anyone who's, let's say you're holding Quicksilver Atom, or let's say Quicksilver Osmo or something, right? Like everyone who's holding that has to have the same distribution of delegation to which validators, right? It has to be like, okay, 20% Chorus, 20% Introp, 20% Sika, whatever, right? But now it's like
they're distributing the risk.
Yeah, but now cross staking is also part of a slashing portfolio, I guess. Let's call it that, right? And so we have everyone who has like Quicksilver Osmo. Now, the Quicksilver system also has to make the decision about all the cross staking that happens as well with Osmo. So that way everyone can have a fungible position. So, potentially this is going to further increase the like decision-making power of these like liquid staking providers, which is, a trade-off.
Yeah, I have to digest that a little bit. Can you turn off your WhatsApp? It's like chiming in here. I think it's WhatsApp.
I think it's off.
Oh, okay, weird. I'm hearing some WhatsApp noises. Anyway, yeah. Okay. So potentially we could see these cross-staked assets as part of a risk pool for liquid staking, but they would need to onboard them. Like technically, that's a little bit more cumbersome than onboarding just using like the staking modules shares, right? Is it feasible, or is it like, liquid staking will only work with natively staked assets?
No, liquid staking will work here as well, right? It's just that all the liquid staked Osmo will also have the same cross staking distribution as well.
Okay. And what if you've got some Juno and like Juno Osmo liquidity pool, right? And you've got some bonded tokens in the pool. You've got bonded Juno on Osmosis. Are you going to be able to stake those on Juno? Even like liquid, like some kind of super fluid staking, but that goes cross chain.
Oh, well, yeah, super fluid staking cross chain. If you remember, we had this exact idea. All right. So I would say even cross staking, this idea we had in some proto version last year with interfluid staking, right? So
Mm,
what was interfluid staking? Interfluid staking was saying, hey, we have this like, let's say Osmo AKT pool on Osmosis,
yeah.
and it's superfluid staked on Osmosis. Why can't we also have that count towards security on Akash network as well?
Mm,
And that is cross staking, right? But instead of cross staking for native assets, it was cross staking for a superfluid asset. So
yeah.
interfluid staking was exactly this idea of like cross staking plus superfluid. And
Yeah.
so it's kind of funny that we actually had this like cross staking idea for this more complex thing of superfluid, and then we're like, wait, we can actually use this for the native assets as well.
Okay. Yeah. I had forgotten that we had already interfluid staking.
Well, we don't have it live yet, but that was this idea that we had. And I think now, like, it takes some time. Like, you have all these ideas, and then they all just, everything just starts to click. And you're like, oh, of course. There's like one unified framework that explains all of these things.
Yeah. No, this is super cool. I'm
And I,
like,
and I, I do think like interfluid staking is an important part of how osmosis is like, makes itself more essential to a lot of these chains where it's like, hey, look, all you Cosmos chains, you already use Osmosis for your liquidity, and you
yeah.
have all of your tokens on our chain. You should be okay with using us for your security system as well. And so it's like, I think there's this interesting relationship that's going to happen between liquidity and security.
And do validators need to do anything different, or are they just running the same software and they
Nope,
don't have to do
validators don't
anything?
have to do anything different.
Okay. But validators can't also opt out of being like if they're staking on the chain that has mesh security enabled, like a validator doesn't really have an incentive to opt out of it.
No, it's just
No.
like as if someone staked more on you.
Yeah. Right. Okay. Interesting. Very cool. Yeah. Well, I'm looking forward to seeing this develop. As as you said, next year. When are you shaving your head?
No more shaving.
So yeah, when we talked in Medellin, when we did this episode with Cryptocito, you were talking about permission smart contracts, like permission CosmWasm, and I've been thinking about this ever since. And like, I mean, yeah, what's the idea here, and like, why do you think all the chains should just enable CosmWasm as a like default permissioned system?
Yeah, because I think like CosmWasm, like smart. So the Cosmos SDK is like very powerful, but very dangerous because you are writing like native code, right? And this allows you to do a lot of really cool things, but it's dangerous. Meanwhile, CosmWasm is this VM system, right? It's like a nice sandboxed environment that you can do like it's way less. It's not as powerful as an SDK, but it's because of the sandboxing and everything, you can the attack surfaces are actually much lower for logic that's written in CosmWasm. Because if you write a new Cosmos SDK module, we have to do like a lot of auditing to make sure it doesn't go like screw with like another module in an unexpected way and stuff, right? Because it's all Go code; they can all call each other. We built this like object capability system to kind of help, but it's not as good as the sandboxing system of VMs. So that's why it's like for new logic, it is just so much faster to like hack on it and like get a MVP and like start building it on CosmWasm. And more importantly, it's so much faster to review it and feel comfortable adding it to a blockchain. And so that's kind of why we've come to the conclusion that how we've started to think about things more is that, hey, let's treat the Cosmos SDK as like kernel level code, right? Like when you're like building
Yeah,
OS, it's like, okay, yeah, you need to do some kernel level programming. But then a lot of the like application stuff that doesn't need, you don't give pseudo privileges and to like things that don't need it, right? And that's like
yeah,
most things in CosmWasm, and then use the SDK where we really need to, like how we do transaction fees and how we do like parallelism and how we do like all this like really interesting staking stuff. Like that can be in the SDK, but like a lot of let's move more of our logic into CosmWasm. And Osmosis, we actually have now, not in the next coming upgrade, we're going to have our first module that's in CosmWasm, which is IBC rate limiting. And IBC rate limiting is a way of like, we can say, hey, we only want maximum of 20% of this IBC channels TBL to like flow out every 6 hours or something. So that way, if there's ever a hack or something, it's like, okay, we're capped at the amount of losses, right? At 20% or something. It gives us time to pause the chain or whatever. And so it's like a similar situation here. But it's like, okay, we're just going to write this in CosmWasm. It's way faster. And if other chains want to adopt this IBC rate limiting module, well, they got to adopt permissioned CosmWasm so they can add it to their chain, right? And like, and so we're taking a very much just like, and the same thing happened with mesh security, where we're like, hey, all this mesh security stuff that we wrote at the HackWasm, we wrote it all in CosmWasm. And I think what's going to happen is like more and more of, especially this like whole interchain composability stuff, is going to start to be written in CosmWasm just because it's faster. Not faster from an execution perspective. Actually, Cosmos SDK is more performant, but I mean faster from a development standpoint. And I think the composability is just gonna, and chains that don't opt into this kind of stuff, use permission CosmWasm, they're gonna like not miss out on all these like cool things like rate limiting and mesh security and stuff. And I think it's just gonna be an incentive for chains to all start to adopt some permission CosmWasm. And human hash, it should be permissioned because like, we don't want every chain to just turn into a generalized smart contracting chain. It should be like, but it should be, governance can add new functionality as needed without having to go through. And another cool thing of CosmWasm is you can add functionality just via governance proposals rather than having to like do a software upgrade and upgrade the chain every time you want to add a little bit of new functionality.
Yeah. No, I mean, all that makes sense. So is there a point where, because I mean, you mentioned the performance benefits, and obviously like writing a Cosmos SDK module is going to benefit from much better performance because it's closer to Tendermint. It can interact with Tendermint directly through ABCI.
It has native code. You have control over how your like storage and database and everything works. Yeah.
Right. So is there a moment where, say, let's say mesh security gets adopted, it's like widely adopted across the interchain, and we realize that like, hey, there's a benefit if we write this as a Cosmos SDK module. Does it then make sense, or do we just like keep kind of trying to optimize this contract? When does this like quickly written, code become core enough to start building modules?
Yeah, I mean, that's a good question. I guess we don't know yet. We haven't hit those bottlenecks yet, but I mean, there's two answers. One is we definitely have to improve the performance of CosmWasm, right? Like CosmWasm today, like honestly, to me at least, the storage is a little bit of a black box. Like I don't know how it. First of all, I know it's like JSON serializing things, and like I don't know how the Merkle tree is working underneath. And it's like, okay, we probably should go and improve all those kinds of things. And like, I think we can get the CosmWasm performance to be like much closer to the SDK. I don't think it'll ever be as good as the native SDK, but we can get it much, much closer. And then, I think maybe some things maybe should be rewritten in the Cosmos SDK, especially like things that happen very regular, like that are extremely important. One cool thing about how CosmWasm works that like is they have this concept of pinning contracts, where what that means is like, hey, a contract that's used so regularly, governance can pin it, and what that means, it'll store that contract in memory, and so that way it doesn't have to keep pulling from every time that contract needs to be called. It like doesn't pull it from the contract bytecode from the database every single time. It's held in memory, just like Cosmos SDK. Go code is always held in memory.
It's like validators and node operators are holding this contract in memory.
Yes, exactly. And so that way that will definitely help improve the performance and stuff. So yeah, long story short, I think there's a lot of work that we can do on like improving CosmWasm performance to get it closer to the SDK. And then if things really do need to be moved into the SDK, and that is like the big win, we can do that as well. And our team has been working a lot on like improving this whole CosmWasm SDK overlap, because I think, like, a little bit of what happened was there was this dichotomy, which was like there were some teams that know Cosmos SDK really well, and there's
Which
some,
teams are those?
I don't know, everyone who's like helps. Most of the teams know Cosmos SDK pretty well, right? Like, your regen who like builds Cosmos SDK.
Yeah,
Our
yeah,
team had forever only been doing stuff in Cosmos SDK. Then you have some teams that know CosmWasm really well, like the Juno team, right? I think they know CosmWasm really well. The Confio team, obviously, they built the thing, and they obviously know the Cosmos SDK pretty well as well. But like, most, the chains that they've launched, like Juno and T-Grade and all these things, they are like very thin Cosmos SDK chains, not much customization there, because they've decided to build all of their logic in CosmWasm.
yeah.
Osmosis, we're like one of the first few chains that, we don't have we have a really complex Cosmos SDK stack, right? All of our AMM logic and everything is currently in the Cosmos SDK, but then we also have this CosmWasm thing. And so when we started doing stuff with CosmWasm, we're like, wait, so much of the CosmWasm like developer tooling and everything was really assuming a very bare bones Cosmos SDK chain and assuming that all the stuff is going to be built in CosmWasm. And that's just not how we're building, right? We're building like half in Cosmos SDK, half in CosmWasm. And so we've had to spend a lot of time in the last few months like really making that UX of like interacting between Cosmos SDK and CosmWasm much, much better. So we've like built this library called Osmosis Rust, which is like a general eventually this is all going to go into a product we're calling Beaker, which is like the we intended to be like the hard hat for CosmWasm. Hard hat is like the tool a tool that everyone in Solidity uses to like do all of their testing and scaffolding and everything, right? So Beaker will become that. So that it'll include like ways of CosmWasm contracts calling SDK modules. It includes a brand new CosmWasm testing framework that we created, because earlier, like, it was weird. What was happening earlier was like the popular CosmWasm testing framework is called CW Multitest.
Mm-hmm.
What they expected was every time you write an SDK module, you would effectively rewrite it in Rust so that you can test it. And like, that's kind of crazy, right? We're not going to like rewrite our code twice, once in Go and once in Rust. And so our new testing framework, we have it so we can actually test, we can write our contracts in Rust, but the modules in Go, and we can still test them against each other. So, our team has been doing a lot of this like work in like making this like two universes sort of come together into one cohesive developer experience.
So this Beaker thing, for those like me who are like more used to like Web 2 development, what would that be analogous to in Web 2? Would it be like a React or more like a what like?
Yeah, kind of like a React. Not really a React. It would be more like, to be honest, I haven't done like web development in a long time, but
Yeah.
like, it's the. I mean, look, if you've done Cosmos SDK stuff, right? It's like Starport, but like
Okay.
Awesome and
Right. Okay. So like kind of a CLI scaffolder
CLI scaffolding,
framework. Okay.
yeah, but also very importantly, a testing framework, right? Like
Right.
that's like
Yeah.
so you have in Ethereum, people coming from Solidity, you have things like Hard Hat and Foundry or Truffle was like the really popular one back in the day.
I think Status also had one. Also, yeah. Interesting. Okay, so this is what you guys are building, and this doesn't exist yet in CosmWasm. Like, there's no real.
No, yeah, yeah.
Because I saw like Larry 0x, I saw him tweet this thing today. I wanted to ask you about it. Is this CW SDK roadmap he's tweeting about? Is this do you know what this is?
Yeah, Larry has this idea that he wants to rewrite the Cosmos SDK in Rust.
Okay.
And he wants to like rip out all the Go and just like make everything in Rust. It's okay, I mean, look,
Isn't Informal also kind of working on this, or aren't they writing like big parts of Tendermint and?
Yeah, so they're rewriting Tendermint in Rust, right?
Okay.
I wish Larry luck. I think it's a fun project. I just don't think. I think the Cosmos SDK has been in development for like over 5 years now, and there is just so much that goes into building an SDK. You have to like, it's not just the execution state machine, right? You have to build like signing systems, you have to build RPC, you have to build like, there's like, it is a massive task that takes like years to build, and we think that it's easy. And we're not saying the SDK is perfect. I promise you, it is not. There's a lot of room for improvement. But I think it'll be much easier to fix the issues with the SDK than it would be to like try to write a new framework all from scratch again.
Yeah, that seems like a massive undertaking. Yeah, I want to get someone from Informal on to talk about like this tenement Rust thing. Yeah, let's try to see if I can get someone. Yeah, one thing I think I tweeted about this, and I was asking like if you have permissioned CosmWasm on your Cosmos chain, and then you also want to have permissionless. Is that like the same namespace, or should the permission stuff be kind of segregated and separated for security reasons, or should the permissionless stuff be able to call the permission stuff?
If you have permissionless, I don't see why you would have permissioned at all, right?
Okay, but there's no security issues of like having these kind of core contracts like Osmosis, right? You've got like your mesh security contracts and stuff like those. Like if you're thinking of like software development, there's like namespacing and sort of encapsulating certain things.
Yeah, it's like Cosmo. That's kind of like what I meant by this whole like security permit, like sandboxing of VMs is like VMs contracts are sandbox, like are private by default, and they need to expose.
Right. Okay.
Cosmos SDK is the opposite. It's kind of like everything's a little bit public by default, and you need to like build in security systems perimeters around things. So it's like, yeah, if you have a permissionless system, it's fine. You don't need to have a separate permission CosmWasm system because every contract is already sandboxed.
Okay, so with CosmWasm, you don't have the same composability as with like Solidity contracts.
No, you do. It's just that like what I mean is like let's say you have a mesh security contract, right? You can't. It's not like any contract can just call in. Like it's easy for a contract to say, "Oh, I only want these contracts to interact with me." Okay, here's an interesting feature that is built into CosmWasm. It's really cool. It's called a pseudo message. So what that is it's a contract. It's a function in a CosmWasm contract that can only be called by the Cosmos SDK. So you can't have another contract call it, and you can't have an account call it. And so this is how IBC rate limiting works, where we have this like rate limiting contract. We don't want it to be called by any other contract or by a user. That's not what it's for, right? So what we do is we use a pseudo message so that the IBC Go module in the Cosmos SDK, it can call this function in this rate limiting contract, and only an SDK module can call that. And so that's a really cool feature that like Fry had added into that CosmWasm that really makes it that's what makes it possible to write, I would say, core modules of the SDK in CosmWasm, because they can only be interacted with by other core modules from the SDK.
Okay, that's really cool. I had no idea. Yeah, I mean, like I don't code CosmWasm contracts, so like it's helpful to be able to ask these questions and understand how it works compared to like Solidity.
There's a big lack of like tutorials and like for CosmWasm where there's a lot of tutorials that teach you the first 30% of
like
CosmWasm.
The hello world.
Yeah, the hello world, or a little bit, the intro stuff, the basic stuff. There's not a lot of tutorials that teach you the complex stuff, like the pseudo.
Isn't Confio doing this CosmWasm Academy thing?
Yeah, they are. So we'll see how. I'm hopefully that will be like the thing that will do it. For me right now, how I learn CosmWasm is I like every time I get stuck on something, I read through the Mars contracts and the DAO contracts. I'm like, oh, okay, that's how they did it. I'll start doing that too.
Yeah. I think that's probably also how I would try to how to try. I mean, that's also how I learned to code
Yeah,
back in the day.
yeah,
That and Stack Overflow. So yeah, I want to talk a little bit here before we wrap up about kind of Osmosis versus Atom 2.0. We do have to make this a little bit spicy, right?
sure.
And like Jim from your team like posted this tweet, I think like late September, kind of basically describing and comparing the same tenants in in Osmosis and in on the Cosmos SDK. And so like there's liquid staking, interchain security, MEV, and bootstrapping. And both Atom 2.0 proposal and Osmosis have very different views about how this is going to work. I mean, we've already talked about mesh security, but I think and then like staking derivatives and superfluid staking, I think it's kind of easy to wrap your head around. How are you guys looking at MEV, and how differently are you approaching MEV compared to like this interchain scheduler that's proposed by Atom 2.0?
Yeah. So, one of the big things we're doing with MEV, I mean, there's two things, right? So at the Nebular Summit, I gave my talk on MEV, right? And it was, I think the takeaway of that talk was the goal is mitigate bad MEV, internalize good MEV. And so, we've always been talking about this like threshold decryption stuff. I think I have so many talks on it. We've about like, that's how we mitigate bad MEV, right? You want to stop the sandwiching and front running and all this kind of stuff. But what does it mean to internalize good MEV? So there's some MEV that the bad MEV is the one that's like you're doing actions based off of someone else's transactions. You see their transactions in the mempool and you act upon them. And that's like a privacy breach. And that's like why it's bad. But there's some things that you can do that aren't based off of reading other people's transactions. It's just based on reacting to the state of the world and just being the fastest, right? Like, so for example, a liquidation, right? That's like it's not bad. It's actually, if anything, it's actually good for the health of the network. You want liquidations to happen, or even arbitrage, right? Like let's say the price of Atom has moved on in external exchanges, and like someone needs to arb the price of atoms on Osmosis, right? And it's like that's not bad. It's not like no one's being harmed by doing this, right? It's like again, it's a good thing. You actually want prices to stay in sync. But there's still profit to be made, and it's a race to who can get that arbitrage profit. And so these are like good MEV systems. And what we want to do is make sure that profit gets internalized into the protocol and gets like given to Osmos stakers. What we're trying to avoid here is like not have systems like flashbots, which are these like external to the protocol, like these like, I mean, I use this term called validator cartels in the sense that or minor cartels, right? It's like it's an off-chain coalition of people who are like doing this. When instead, all of these auctions and stuff. So what we call them, what we're working on with, so this is where Skip comes in, where Skip is helping build tools for internalizing good MEV. And so what that means is they're doing a couple of things, right? They're doing the proposal that recently went up was about building an on-chain arbor. So this is for, there's pools on Osmosis and sometimes they go out of sync, and then there's an arb opportunity to resynchronize the pools, like do a circular, you sell Osmo for Atom, Atom for Juno, Juno for Osmo, and you get a little bit more Osmo by doing that. And there's a lot of like off-chain arbors who are playing this game right now. To be the first to do that. Well, the protocol can do that itself and capture that revenue, give it to Osmo stakers. So that's like the first thing Skip is going to build. Then the second thing is like, okay, but that only works for internal arbs. That doesn't help you arb against external markets, right? So oftentimes there's a lot of value in being the first transaction in a block. And so we call this top of the block auctions, where, what we should do is sell off the rights to be the first transaction in a block. And that way, people can bid on it on chain. And if they win that bid, they'll be the top of the block and they can be the first to execute arbs and whatnot. So, there's like value in these things, and building these in protocol is what Skip is doing. And like, effectively you can argue that they're basically they're like going to be a core dev of Osmosis and building like functionality into the Osmosis core protocol to do this kinds of thing.
So this top of the block auction thing, then the revenue from that top of the block auction would go also to stakers. So when you're saying like internalizing good MEV, or wait, are you internalizing bad MEV or good MEV?
Good MEV.
Good MEV. So internalizing good MEV is kind of like leveling covering all the bases and leveling the playing field at a protocol level, and then capturing the revenue from that and like giving it back. Because you can, right? Because like with Osmosis, you can. I think with Cosmos, and especially now with interchain security, it's harder to see exactly what that stuff is, because like you guys have a specific, like Osmosis has very specific use cases, and you can kind of target the MEV that you see there. Whereas with Cosmos, there's gonna be like tons of chains there, lots of MEV opportunities, and so I think where the scheduler makes more sense here is, okay, like we don't know what those ARB opportunities are going to be. Let the market decide, and let the market figure it out by having like these like future block auctions, future block space.
So let's talk about the scheduler, right? So there's two interesting things about the scheduler. One is this idea of it being a futures market. That's an interesting thing that I haven't really heard of. And one worry is it's hard to know, like, buy block space for a future block and like try to know how much MEV is going to be in it. It seems and then it seems that all the profit is going to go to this secondary market of like reselling future blocks rather than like more just-in-time sales when the value of the MEV is more known. So that's like I don't know. That's an interesting thing. We'll see how that actually like plays out. But the general thing is that like this whole idea of the interchain scheduler is, it's hard to see which chains are going to opt into this, right? Like something like Osmosis, I don't see why would Osmosis opt into the Cosmos Hub's scheduler and give up, instead of internalizing the MEV to Osmos stakers, giving it to Atom stakers, or even like interchain secured chains, even them, like I've been talking with the Neutron team, and even they are like, yeah, no, we don't plan on using the interchain scheduler because part of the value of the Neutron token was we're going to internalize the MEV into the Neutron token. And so it's like, I feel that kind of one of the benefits of building an app chain was to be able to internalize MEV, and it's unclear who's going to be the user of the interchain scheduler and like opt into not internalizing their own MEV. So that's like a big question.
Yeah, I think they need to clear up like what the incentives are here.
Yeah. So I think here's the most interesting question about how cross-chain MEV is going to work. Maybe there are benefits to having a singular market. Okay, so there's two options here. Let's say every chain has its own top of the block auction, right? Let's say, Osmosis has its own, Juno has its own, whatever, right? If you want to do an arbitrage between these markets, like between Osmosis and Juno swap, let's say, right?
Mm-hmm.
You have to win both of the top of the block auctions. And that's like harder, and it's like more unclear, like, oh, what if you win one but not the other? Now you just wasted winning that bid and stuff, right? So that's I would say the null hypothesis. That's the default of what's going to happen, and I think that's probably how things are going to start off. But there is benefit, maybe, to what if like these auctions were joint in some way, right? Like what if you could say, I want to bid on to be the top of the block of both Osmosis and Juno, and if I don't win both, I don't want to win either, because that's not worth it for me. Now, the Cosmos Hub says, oh, okay, yeah, we'll do that. And the allocator, the scheduler module is like, okay, and then that profit goes to Atomos. It's like, no, okay. Everything's a mesh, right? So it's like, the question is like, okay, I think if it is beneficial for Osmosis and Juno to have a joint top of the block auction, they should do that, and the value should go to Osmo and Juno holders. But the question is, how is the revenue going to be split? Is it going to be split 50-50? Is Osmosis going to get a higher portion of the revenue than Juno will? Because, the liquidity on us, it's more likely that Juno's swap is being arbed relative to Osmosis rather than the other way around. And so it's like, okay, how is that revenue split going to work? Is there like a formalized model for how we define fairness in these like joint auctions and stuff. And like, I think that is one of the most interesting questions and like open research problems that I think came out of Cosmoverse. Or, I guess like I've been talking about it with the Skip people for a little bit, but like I think that we had this MEV panel at Cosmoverse, and I think that was the first time we kind of like shared this big open question publicly. And so I don't know. I think this will be an interesting research topic for a while. How do you do revenue splits of joint auctions?
Yeah, I think the MEV topic on Cosmos and so like interchain MEV is like so interesting, and I've only just kind of started diving into it. I haven't paid much attention to, I sort of like, follow the Flashbot stuff a little bit, but like not that much. But then, I had this interview with Braps a couple weeks ago, and he just like totally opened my mind to this, and then like hearing you talk about it. So, yeah, I think this is something I want to cover a little bit more on the podcast here. Maybe I'll get the Skip people on. Cool. Well, listen, I think we can wrap it up here. It's been an hour. We didn't really get to talk about Osmosis ecosystem so much, but maybe we can save that for another time. So I'd like to try something here. Okay. Maybe this could be like a recurring thing. Who should I get on next?
Who should you get on next?
Yeah.
Have you had Dojmos on?
I have not had Dojmos on.
Dojmos would be a good person. Have you had
specifically about what?
Just like Kepler and UX and how like building cross-chain wallets and like it's all this sort of. Have you had any Mars team on?
I have not, but so we were supposed to do it next week, but I think it's going to be pushed back a little bit. But yeah, they're due to come on as well.
Cool.
All right, Dojmos and Mars.
I think Gitopia is really cool, so also get them on as well.
Who?
Gitopia. It's GitHub
Gitopia.
on.
Oh, okay. This is cool. Okay.
I know you would really like that kind of stuff. Yeah.
Those are 3 great suggestions. All right. Well, Sunny, thanks a lot. Thanks for coming on, and hopefully we'll get you on again. I know we'll get you on again for sure. Sometime very soon. Thank you for listening to yet another episode of The Interop. We do live streams every week. Please follow this channel, subscribe to this channel to get notified when new live streams go live. You can also follow me on Twitter. I'm at Seb 3.0. I tweet about all kinds of things related to Cosmos and the interchain, and sometimes some other stuff. But yeah, thanks so much for joining, and we'll see you next week.